Assalamu alaikum. We are trying to solve example 2.7 now. So let us copy this circuit, and they told us to calculate the current I0 and the voltage V0 from the given circuit. So this is example 2.7. Let us paste the circuit in the canvas and let's do the calculation. So we see that we have a node over here. So in this node, the 0.5 I0 current is entering and the 3 ampere current is also entering and the I0 current is leaving. But before applying the KCL part, we see that we can apply Ohm's law over here, and we can write that V0, the V0 current we had earlier over here. So this V0 is 4I, 4I0. So V0 is 4I0. We got this equation by using Ohm's law. Okay. So after that, let us apply KCL at node A. KCL is applied on a node. So that's why we apply KCL on this node A. So in this A node, the current that is entering this in this A node, this is 3 ampere current source is entering, and the 0.5 I0 is also entering. So 0.5 I0, 0.5 I0 is entering, and the current leaving is I0. So it's quite easy to calculate I0 from here. So I0 can be, let me see the answer, because I do not want to do the calculation. It's almost 12:30 now. My head is not working at this moment. So I0 is 6 ampere. So from calculation, we see that I0 is 6 ampere. Now, after this I0, they told us to calculate V0. So I0 is 6. So V0 is 24 volt. So 6 ampere and 24 volt. Yes. So the next problem is practice problem 2.7. They told us to calculate I0 and V0 again. So once again, we copy the circuit and let's try to solve this. So here, once again, we assume that this node, this is a big node, and this node is known as node A. Let's call it node A. So if we apply KCL and this in this A node, so if you apply KCL at this A node, we see that current entering is 9. So let us write the, uh, sorry. at- So applying KCL at node X, pardon for the font, but applying KCL at node X, we see that the current that is entering is 9 and the all other currents are leaving. So the currents leaving are I0 plus I0 divided by 4 plus this current is not given, but this current is implicitly given, but it is not shown that whether this current is entering or leaving. But this plus and this minus symbol is given, which indicates that the current is flowing in the downward direction. So let us not name this current anything. Rather, we write this current in terms of Ohm's law, which is V0 divided by 8. So I is V by R. So V is V0 and R is 8. So this from this expression, we cannot do anything. So let's keep it in this way and let us apply KVL. But we see that all the elements are in parallel. So we can say that this V0 voltage is applicable for all the elements in the circuit. Okay. So we apply Ohm's law for this part of the circuit, and we see that V0 and I0 can be related by using Ohm's law. So let us apply Ohm's law, and we see that V0, we see that our V0 is twice I0. So V0 is twice I0. So we can replace V0 everywhere with twice I0. So let us replace. So right now we have the expression for I0. We can simplify it. So 9 is equals to this is I0 by 4. So I0 plus twice I0 divided by 4. So this gives us this is 4, this is 4. So this gives us 6I0 divided by 4 is equals to 9. So we have I0, I0 is 9 multiplied by 4 divided by 6 ampere. So this gives us 6 ampere. I0 is 6 ampere. Since I0 is 6 ampere, then V0 is 12 volt. So I0 is 6 ampere and V0 is 12 volt. V 6 ampere and 12 volts. So example 2.8. Example 2.8 is quite easy to solve because it was the pre-lab question of our experiment 2. So let us solve this circuit for now and go to sleep. Okay, so they told us to calculate I1, I2, I3 and V1, V2, V3 for this one. So let us imagine that we can make these two resistors parallel. So these two resistors in parallel will have the equivalent resistance of 6 parallel 3. So we can write 6 parallel 3 ohm, which is 2 ohm. So we can write directly 2 ohm. So this is 2 ohm. Okay. So we can apply VDR directly, and we know that in parallel circuit voltages are the same. So V2 and V3 are equal. So V2 and V3 are equal. So you can write V2 is equals to V3, and this V2 or V3 can be calculated by using voltage divider rule. So this equivalent resistance is 2. So on the top we will have 2. The multiplied by the voltage that is being divided is 30 volt and divided by 8 plus 2. So this will be our V2 or V3. So this is 6 volt if I'm not wrong. 10, 3. Yes, this is 6 volt. Okay. And V1 can be written by using 30 minus 6 volt, which is of 24 volt. Okay, so V1, V2, V3 are found. Now it's time to calculate I1, I2, and I3 by using Ohm's law. Since we have I1, let's calculate I1. Okay, so I1 is V1 divided by 8. So V1 is 24 divided by 8 is 3 ampere. So I1 is 3 ampere. Okay, so similarly I2 and I3. So I2 I2 is V2 by 3. So V2 is 6 and this is 3. This is ampere. So I2 is 2 ampere. So this leaves us with only I3, and I3 will be 3 minus 2 ampere. So which is 1 ampere. So we have V1, V2, V3 and I1, I2, I3. So I do not think we should continue anymore because we are very tired. So thank you very much. Assalamu alaikum.